Hello, folks.
Hey,
Welcome
guys.
to Rational Science. You got ons today. You got them back.
Hey guys, you found me.
Yeah, I don't know where he was hiding. Anyways, we're going to have a great day today. We're going to be talking about what? The center of the universe.
I thought the shape of the universe.
No, the
As
shape.
well.
No, that was last time.
Oh,
But
yeah?
yeah, we did shape, but it's a related subject. So, like the center, it's like you need a shape. So
Yeah.
let's work on that today. But anyways, let's begin with our extinction segment. We usually begin over there. Subject: we don't usually do politics here, almost never. Only in relation to the global economy or maybe some history, historical fact or whatever. But here was an interesting tidbit this week. We had good old Assange, Julian Assange, WikiLeaks founder, and he was left off the hook by the Justice Department. Reached an agreement with Julian Assange to plead guilty to a single felony count of conspiring to unlawfully obtain and blah blah blah. Okay, and what's he going to get? The deal is expected to effectively bring to an end to a years-long legal battle by the U.S. to prosecute Assange. Okay, so he's off the hook. Okay, and that's exactly what I said in an article that I put out there. Okay, for those of you who are not aware, a few years ago they put out some kind of article, and it said this was the face of it. Do you want to know a secret? Right, and that's how they promoted him. And I added something to that a little bit, right, that would help you put him in the right context, and that is, he wouldn't nearly be successful if he were for real. And there you see the link in Quora where I wrote the article. I keep updating it every now and then. I updated it the other day when this article came out. And here you see, this was 2012, and these were the bobbies in England guarding the Ecuadorian embassy where he was cooped up in. And you can see him there. He's talking, right? This is 2012. You say, oh man, the whole British government is after this guy just to send him back to the States. And just 5 years later, he was still out there hiding from everything, from everyone in the Ecuadorian embassy. And here you see him out on the streets with his girlfriend, who became his wife, right? They had 2 kids, all under the auspices of the British government. Okay, that's him in England, out on the street, in London, out on the streets. So, well, that's just a little tidbit for you. So you can check the link there and go to Quora and find out what the story of Assange really is from my point of view. Okay. Anyways, let's talk a little bit about extinction. Here we have a fellow everybody knows, Warren Buffett. And what is he saying? He's saying that the economy's become more and more specialized. 19th century was an agrarian economy, and he's absolutely right. And that's changed quite a bit today. And so the important thing is not only that, but he says also it's inevitable consequence. Okay, so we had no way of avoiding becoming more specialized, more efficient, right? Technology that we put into the system. Okay, so keep that in mind. We can't reverse it.
What can't we reverse?
Well, we can't reverse going back to the days of hunter-gathering. I don't think there's enough animals out there that we can hunt and gather. Now people look at that and say, well, that's evident. But then can we go to agriculture where everybody, 8 billion people, are farmers? And I doubt that very much. And so the question is, can we also go back to manufacturing, where manufacturing is 90% of our global economy instead of the 85% services we have today? And the answer from me is no, we can't. We can't reverse that process.
Well, I mean, science kind of made it impossible to go back.
Right, we made everything so efficient.
Sorry, technology.
So we become much more efficient, right? And you can't undo, what do we call it, knowledge?
Yeah, we can't put the
We were talking about knowledge the other
can't put
day.
the genie back in the lamp. In
Right.
this case.
Once you know something, once you know your wife is cheating on you, you can't undo that. Hypnotism, maybe? I don't know.
Once you know, you know.
Yeah, okay, so here we have another fellow, and his name is Ray Kurzweil. And the problem with this guy that I have is the word that they use to describe him, which is the word scientist. He's no scientist, okay? What does this guy say? Well, he says that we're going to invent these bots that are going to come into our bodies and crawl through our veins or whatever and make us live longer because they're going to be smart bots.
Oh, nanobots. Yeah, I know.
Yeah,
Those
nanobots.
From video games, I know.
Yeah. And you wrote a book recently. I guess he's promoting it. But Ray is one of the fellows who's out there promoting the singularity, technological singularity. He says that once we reach that point, technology is going to expand exponentially beyond our wildest dreams. And I think he's talking about the extinction of man, one way or the other. We're going to become extinct, and what these people have in their minds, I have no idea. But yeah, we're not going to approach any singularity unless you say that singularity is what, extinction. Then I'll say, yeah, we're approaching extinction.
Well, it does kind of beg the question, just out of curiosity, what are the latest, most crazy technological advances we will make before the human race goes extinct?
And I'm saying that
You always say there are no new
No,
technologies,
right,
but that's
and-
obviously false because we have AI now, which didn't exist 20 years ago.
okay, but let's even concede that. Let's assume there's one or two new inventions.
What's the weirdest?
We're not making inventions like in the 19th century where we were discovering a lot of stuff based on electronics and magnetism, right?
Okay.
Where we were seeing, hey, we can do this with magnets. Hey, we can do this with electricity. You know, and so we had all these things. Then when we did gravity, you know, the airplane, etc., and balloons and so on.
Yeah.
So we started playing around with all this stuff, and there was a lot to invent because we hadn't invented anything. It was an agrarian economy. And then suddenly we begin inventing all these gadgets that help us do what the cotton gin helped us pick cotton faster, you know, and manufacturing of all kinds. We built the car, we did the telephone, the printing press got modified quite a bit. Photography came into being, you know, so we made a lot of the telegraph, right? And so we made a lot of inventions that suddenly, you know, brought us into what we'll call it the 20th century, like to modern age. And that was a period of maybe, give it 100 years, more or less. And now that's over. 1980, we started the service economy, and manufacturing. Anything that we invent today is not going to blow the field wide open in manufacturing. That's what I'm saying. So whatever we invent now is going to be marginal increase in from an economic point of view. You know, it's not going to increase our manufacturing base at all.
Yeah, obviously.
Manufacturing is on the way out.
That's because we already came up with the machines that build machines, so now we don't need
Exactly.
people in manufacturing besides the guys who fixed and build these machines.
And so what I'm saying is
that's
we're
not the question.
moving
The
into
question was more, what are the weirdest technologies that we will assemble before the human race goes extinct?
And I'm
What's
saying,
the weirdest stuff that
well,
AI and such is going to show us?
well, my answer to that also is the Jules Verne kind of thing.
Yeah.
You know, when Jules Verne in the 19th century, what was it, 1890 thereabout, he said, look, man is going to travel to the moon. Well, at the time it was science fiction, it was impossible fantasy, right? And for those who believe that we went to the moon, you know, eventually we went to the moon. And if not humans, many people at least can see that rockets have gone to the moon, right? And so the question is, you know, that was something that was in the cards. That was something within the possibilities within physics. Whereas, you know, if you say, look, we're going to invent going through the fourth dimension.
Okay, yeah.
Now we're talking
I'm talking about real technology,
right, and
not
so,
weird.
And so that's my point. My point is, right now we have very little to invent that will really blow the field wide open. Like Kurzweil says that we're going to hit the singularity, technological singularity, where we...
In theory, there are some theoretical ones that seem like they're in the realm of going to the moon, like nanobots, like AI, like bioengineering humans. There's a few that are cloning people. There's a few that are heavy-hitting technologies that seem on the horizon. And those are the ones I'm talking about that are really weird but doable. It's not traveling through time or fourth dimension stuff. It's graspable.
Yeah, but the
Things
question is,
that
will they change? Will they change our way of living, or really blow the field wide open
in
in the sense
theory
that?
they do. Not blow the
But
manufacturing.
then
It's
should
not
be
going
able
to
to
bring
imagine
back.
what
Hold
we
on.
need.
It's not going to bring back the manufacturing age. That we agree. But it will unravel some very important strands of the fabric of society.
Yeah, that might be true, but I mean,
That's
my point is, what can we imagine? Because one thing, before you can build something, you have to imagine it, right? Jules Verne again, if he said,
Yeah.
"Hey, we're going to go to the moon with a
nanobots.
rocket or whatever,"
This guy's talking about
had-
nanobots.
right?
That's envisionable.
Okay, so you can envision something like that, and you
Yeah.
can say, okay, if I can envision it, I may be able to manufacture it, right?
Maybe.
But if we cannot even envision new things that we need,
Nanobots again. That's one that you can envision.
yeah, that goes through our bodies.
Yeah.
Yes.
Micro robots that
Now,
go through our
that
bodies.
does sound quite science fiction, but concede. Let's concede it. Let's
That
assume
one
that's
would be a
true.
weird one.
But that's got to do with health, I guess,
Yeah.
in that sense,
Yeah,
right? In
yeah,
that
yeah.
context. And I'm not sure. We want to live forever. I mean, people say, "Oh, I would like to live more years or forever." But if we live forever, we don't have kids, or we crowd the
Yeah,
planet,
it gets
and
weird.
so I don't think it's a good idea for society to have people who live forever. We're living too long already. We used to
Yeah.
live 40 years. Now we live like me. I'm already going on 72 this year, so I don't recommend it.
The question of what future sciences will allow us to do, matching what we really want to do, that's a big philosophical discussion.
Or what's good for our
Yeah,
society.
what's good
right?
for our society.
This is what I think is really going to happen. Here we have World War III. It's too late to stop World War III. And the guy goes over 3 possible scenarios. He says not one of them is probable. And what is he talking about? He's talking about, there could be a war because of Iran in the Middle East. There could be a war with China, another one with Russia because of the Ukraine war. And he suggests that none of them is probable, okay? But my take on that is that, the human race is coming to an end. Really, let's put it a little more global. The mammals are coming to their what is known as the sixth mass extinction. I don't think we can avoid it. We're going to be part of that process. We're going to come down together with all the mammals because we're going to liquidate them before we go, more or less. A lot of them will disappear. People will hunt anything to stay alive, right? But I think the mammals are on their way out. They're already on their way out. Lots of animals are disappearing, species. Others are shrinking in numbers, and we're trying to save them. You have all these people out there trying to save them, and I think it's just like taking water out of the Titanic with a little cup. The ship is going down no matter what. That's one issue, and so I don't know. I think that World War III is going to be part of that. At the last moment when all is lost, I think some people will start pressing the button. They won't care. They won't give a damn.
There is a big rise of nihilism and hopelessness kind of in the air, I notice, with a lot of people. Kind of goallessness and stuff, and that I think would contribute to people pressing the button also more, where they say, well, it's the end anyway, so let's see some fireworks. Kind of.
Right, and that's what I'm saying.
I hope that doesn't
That's
happen.
one issue. The other issue, we have to superimpose on that. We have to superimpose on it the fact that we have Calhoun's experiment, and nature's doing Calhoun's experiment with us. So, we have all these autistic people out there, people who are homosexual, and we're saying that that's got a lot to do with the fact that we lost our genetic diversity. And that's the argument here. You don't have to agree with it, but it's something you have to research and take into consideration. Okay, moving on here, I'm going to just touch upon a couple of questions that people made, comments and questions people made. Here's the first one. Fellow says, 2D is conceptual only? Why? Okay, and the answer is because 2D, take a square, take a circle, whatever, any plane that you want, triangle, right? It doesn't exist. And so it's an object. It's an object by definition because it has shape. Square has shape, circle has shape, triangle has shape, they have shape. But they don't exist, so they don't have location. and that's what's missing in that. So the only way you can only imagine them. You can draw them. Even when you draw them, well, the square, is an object, but keep in mind what you have on paper is just ink and pen, ink and paper. That's all you have on the paper. But you can't make, a square out here, right? Or a circle, or triangle. So in that sense, I'm saying it's conceptual. It's an object, yeah, but you can only imagine it. You cannot really produce it.
There's no such thing as a circle.
And yeah, because even if you want to produce it, what are you going to produce it of? Atoms, and atoms are already quite thick. Okay, so thicker than flat.
Quite thick. I'd say they're quite thin.
No, atoms are very thick compared to flatness.
Oh, okay.
To plane.
Compared to a plane.
Right. And here you have, just in case, you have to factor this in with it. Okay. Here you have the circle. Okay. And the circle goes down, right? And you can't see it sideways because right now you're not having a circle. What you're having is an oval. Elliptical thing there of some kind. Once you turn it sideways or back to front or whatever, any movement that you give it, you distort it, and it's no longer a circle. You can't call that thing a circle. It stopped being a circle. And sideways completely, it should disappear because it has no thickness. And here, the same thing for the square, okay? You see it there? So yeah, you can't really turn these things sideways. First, because they stop being a square or a circle, triangle or whatever, and second, because if sideways you can't see them, and it wouldn't make any sense. And we're going to bring that up again when we talk about now with the infinite universe, whether it's a plane, right?
Oh, I wasn't listening. I was reading the comments. I'm trying to understand. Sometimes what people write.
Okay, here's another fella who talks about what? He says, what a crackpot. He's referring to me. Okay.
Yep.
Try explaining empirical.
Right.
Try explaining the empirical evidence. Empirical evidence. He's talking about experiments and the fact that I'm going to convince you, so I'm going to present evidence, I'm going to persuade and try to convince you and try to change your mind. And he thinks that's part of science, changing minds.
I think a lot of people think that's part of
science.
Yeah, I know. I wouldn't blame them.
Yeah, okay, that's where the problem is.
Yeah.
And he says, like the expansion, CMB, the background radiation, right? GR has been validated. He wants validation. He wants someone to go out there, do an experiment, prove it to him, validate it to him, right?
Yeah.
And he doesn't understand that he's the guy who it's been validated to, not to me.
Well, he's talking about convincing.
Yeah, and then he talks about GPS. GPS is technology, has nothing to do with science, okay? And, does GPS prove that gravity warps time?
To whom?
Right,
To whom does it prove? That's why I love the word. Whenever anyone says prove, it's been proven, always follow it up with to whom.
Yeah.
To whom is it proven? And you sound like a conspiracy theorist or a crazy person, but that's just logical English. That's a normal way of talking. You can't just say, it's been proven.
And then he talks about evidence,
It's been proven is like saying it's been stabbed. Who has been stabbed?
Right. It's been
what? It's been said. By whom?
Right.
Who said it?
Okay, and here we have another fellow. He defends Ayn Rand. Some call him, I call her Ayn. Okay. Says the YouTube video exists independently of me. The fact that it exists implies what? That I can perceive it and that I exist possessing consciousness. Perception and consciousness have absolutely nothing to do with exist. But that's what this fellow believes. This is what he proceeds with. This is what he's got in the back of his mind. And so he's going to defend that. Perception and consciousness, which have nothing at all to do with existence. And then he talks about the theory of concepts and schools of thought of concepts. The objectivist position is concepts are what? The products of a cognitive method of classification whose processes must be performed by man. In other words, he puts man as the center, the observer, right, of the whole thing, but whose content are dictated by reality.
Oh, you're gonna have to simplify that. What does that mean?
I don't know. I have no idea what all that means, and we don't care because it's very simple. And here we have Ayn Rand's words, her own words. Okay,
Wait,
so
why'd you put it if we're not gonna dissect it?
Huh?
Why'd you put it up if we're not gonna dissect
Because
it?
I'm going to dissect whom he referenced, which is Ayn Rand. Okay, that's why it's better to dissect her.
Okay.
And she says, "What is to exist? Exist is to be something." Well, okay, that's a starting point. Okay, it's not completely true, but it's a good starting point. It's got to be something. And the question, what is something? I mean, can we say that motion is something? Because motion is a noun in ordinary speech. You could say it's something, right? Even nothing is something to some people. And they say, oh, that's something. So the question is, exists is to be something is not very clear yet, right?
Yeah.
To be an entity of a specific nature made of specific attributes. So she's going to go into what an entity is. She says things, in other words, entities, right? So she says things and entities are synonym. We agree there. But then she says, what is entity? Sight and touch. And that's what it's always been to everybody out there. Everybody thinks that a thing, right? Anything, something, entity, figure, object, all these words are synonyms. What is it? Sight and touch. That's how we determine it. She's talking about perception. That's what this fellow was talking about. This is where he got it all from. And then she says, existence exists. Whatever that means. That's good for poetry. It serves no purpose in the science of existence, which is physics. In physics, we don't say existence exists. No, existence is a concept, so you can't say that a concept exists. And then something exists, which one? What? Perceives. Yeah. So Ayn Rand had no idea what the word exist means or what a thing is, an entity is.
Well, she had an idea, but it was a faulty one.
And there I have the perfect example. The quadriplegic who can't see. Okay, so he has no touch, he has no sight. Does the moon exist for him? Does the chair exist? He can't touch it or see it. So does that mean the chair or the chair he's sitting in, it doesn't exist because he can't feel it, he can't see it? So no, see and touch are not our irrational criteria to define exist. And obviously she didn't know what an entity is because she referenced it to perception, to consciousness. And that's why I know Ayn Rand never figured it out. Like no other so-called philosopher, Wittgenstein, Hume, even all the way to Plato, none of them figured it out.
I think people have made that mistake for, like you said, millennia,
Oh,
where they equate reality. Some people, I was even watching videos yesterday where they straight up say, yeah, reality is subjective. They say it as such.
Right.
Like, and because
so if I'm high on drugs,
it's one of those. It's one of those. If the tree falls in the forest and no one's around to hear it, kind of things. I don't know why it's so hard to conceptualize that the universe goes on without anyone watching it.
Right, and the question is, was there sound? Sound is, so you have to define these words.
Yeah,
say, okay, what is sound? Sound is rarefaction and compression of air, right?
So when the tree falls, it does that.
If it happened, it happened.
Matter
Whether you heard it or not, whether the deaf man heard it.
Exactly.
Or the blind man saw it.
It's not that hard. But
so what do we do in science? Well, we define exist so that we don't have any problems. We say exist, physical presence. What does that mean? Physical means object. There has to be an object. And good old Ayn Rand had it right there. What she forgot is location. She never figured location out. You need location. It's got nothing to do with perception. As you can see, there's no provision in there for belief or knowledge or perception or any other things that people usually introduce there. You do not need to touch. You do not need to see. Obviously, if the Klingon on the other side of the universe has a chair, I can't see it or touch it. But does that mean the word chair does not refer to an object?
Can I ask something about this one?
Sure.
So we have physical presence. That means there are many things in the universe that we cannot see or touch.
Yeah.
There are many things that exist that we do not know of, or we cannot know of because they're just too far, they're too silent, they're too quiet.
The rope.
For example, there's a lot of things that we cannot discern the existence of.
Right.
That's what you're...
Yeah, in other words, see and touch are poor examples or poor criteria. I can't see or touch the chair that the Chinaman has on the other side of the planet. So he's got a chair, right? He's sitting on it. Does the word chair refer to an object? That's the only question, right? Did I see it? Did I touch it? No. And does that mean he's not sitting on a chair because on an object because I can't see or touch it?
But then they take also that step further where they say see ability, touch ability. Well, now they're trying to skirt the question.
But that means I have to run an experiment. That means before the asteroid hits the moon, so far the moon hasn't seen it. So far they haven't touched each other. Is an asteroid an object before we run the experiment or the observation?
It's touchable.
Yeah, it's touchable.
I
don't know if it's touchable.
When you say touchable, that means you quickly ran an experiment in your mind that you can touch it.
No, you went into the future. Yeah. Hey, no experiments necessary to define words, okay? And the only thing I want to add there, you have all these irrational statements, some made by theists, others by atheists, and the other ones by agnostics. One fellow says, I know that God exists. The other guy says, I don't believe that God exists. And the last one says, I don't know whether God exists or not.
But those are fine statements.
No, those are irrational statements.
Those are fine statements because they're not sure if he has location.
No, that's not the issue.
Yeah.
No, that's not the issue.
I can say I don't know if Wookiees exist.
Yeah, but the issue is that in the definition of exist, there's no provision for knowledge or belief.
That's not the point, but you can still use the word exist.
No, you can't.
I know that God exists still works with that definition of physical presence.
No, how so?
Because God may have physical presence or may not. I just don't know it.
But you need what you're saying is that your knowledge has something to do with God's existence.
No. That's not what I'm saying. I'm saying whether he exists or not, whether he has location or not, or is physical or not, I don't know.
No, you have to tell me. You can't say, I don't know. You're the guy proposing God.
No, I don't know. I'm a dumbass. I don't know if God exists. I don't know if he's physical or has location. Depends. It really depends on how you define God, isn't it? It goes back to that one because some people say he's a spirit, some people say he's an old man with a wand.
But the presenter, the person giving you the dissertation, the lecture, that's the person who has to tell the crowd.
Yeah. God is.
Yeah, what it is to him, what he's going to present. And he can't say, he can't begin his presentation by saying, I believe God exists, or I know God exists. No, you can't begin like that. You said, let us assume God exists.
I guess you could say
then you can continue, and then I'll concede your assumption because I'm going to try to understand your theory. So I concede the assumption at face value. It doesn't mean I'm going to believe in it. I don't need belief in that whole situation. It's just an assumption. Anyways, let's move on to the main course today, which is infinity. Oh my God, infinity. Here we go. Okay, we're going to talk about the infinite universe, and not only infinity. We've got two things here. We have infinity and we have shape. Last time we discussed whether the universe is infinite or finite, right?
Well, what did we conclude?
And the issue, the issue is that the relativists, they want to include both. They say the universe is both infinite and finite.
Typical relativists. Typical.
And then from there, the question is, what is the center of that universe, right? And what we're going to argue is that if you have an infinite universe, you can't talk about, assuming there's such a monster, right? You can't talk about the center of the universe. That's the one issue. The other one is if it's a finite universe, then you can talk about it. But then the question is, how do you determine that if that's a question of an empirical issue where you determine when you run an experiment or you do an observation and you say, here's the center of the universe. Is that possible? Is that, at all within the laws of probability of man? Can we ever figure that out? Or is it a conceptual issue, right? That's one issue. And again, the other one is if it's infinite, well, forget about that. And so the problem here is that relativists make their universe both finite and infinite, as usually they have all these dualities. They cover all the bases.
Depends on what you're asking.
So it's easy to defend when you make no sense because you covered all the bases. That's the argument. Okay? And so the first thing we have to do in science is define. If we define, then we know what we're talking about.
Yeah, we know what we're asking.
And the problem is no one ever defined infinite or infinity. And here are the definitions you find today. This is out of the dictionary.
Here we go.
Okay? And infinite is an adjective. Infinity is a noun. Okay? And then they have an adverb called infinitely, okay? But the problem with this, as you can see in infinitely, it says boundlessly. If you just look at the green ones there that I marked there, they're talking about things. They're saying unmeasurable in extent of space. They're talking about a thing. They're treating space as a thing. They're talking about its extension, and they say it's unmeasurable. But unmeasurable is not a thing. Unmeasurable means I'm going to be doing something. Okay, it's what they're doing essentially is confusing bounded or unbounded with incessant or eternal or perpetual. What they're talking about is time or doing something over a period of time. They're talking about motion. So when they say the infinite nature of outer space, they're treating space as a physical object. And the synonyms they have for that is unbounded. No, unbounded can only refer to an object, and all objects are bounded. There is no boundless object. There's no endless object. All objects, by definition, are that which has shape.
Oh, by your definition.
Yeah, that's a scientific definition until someone produces a better mousetrap. That's the issue. And so there you have mathematical version. It says having elements that can be put into one-to-one correspondence, blah, 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 blah. Well, that has nothing to do with physics. Okay, in physics, we're just interested in what is the definition of infinite or infinity with respect to some entity, some object, something. Okay, can an entity, object, or thing be infinite, boundless, endless? The answer is no, because by definition, it's finite. It's got shape. And so if you don't like the definition of object, of thing, right, saying that which has shape, good. Bring one that you can use consistently, and we'll consider it. So, and then in the Wikipedia, you see at the bottom, infinity is something which is boundless. Absolutely not. There's no something which is boundless. And again, the reason is they never define what something is, or existence for that matter, and because of that, they never defined infinity.
Well, they're just not as nitpicky with the definitions.
Yeah,
in dictionary.com, which you think is their whole job,
but you have to be picky with the definitions in science, especially the most important words like what is an object, right? Yeah. Object, location, distance, those key words which form the foundations of physics, without which you can't do, right? You must define, and they better be defined, very crisply, very concisely, right? So that we understand exactly what you're saying. If you're going to define them and leave open end, people go on a tangent and say, well, because the definition it's a loose definition.
There is a difficulty there because every word has a notion, which is this like cloud of criteria. Sometimes I say a word and you have a different cloud than I do, and they usually overlap on most of it. But when you define it, by almost necessarily, you're going to be cutting out chunks of that word that I actually want to keep in the word, and so on. And that's why defining words is so difficult, because when you try to define a word, you're defining it for you, for this discourse only, right? Because that word usually means so much more in normal discourse, in ordinary speech. But but words are used in ordinary speech, so that word does have all these many meanings. I mean, the word God is the best example. Nowhere, if you can't find
God is love.
It's so many things.
God is intelligence.
God almost doesn't mean anything anymore.
Yeah, because God is everything.
Yeah,
they even define it as God is everything. Yeah.
Poor guy lost his meaning.
But this is the issue. The issue is even though there are overlapping regions, you have to find, can we use your definition consistently, objectively? And that's, I think, the ultimate criteria for any of these definitions, especially the ones that form the foundations of physics, right? Because if you're going to talk about existence, you're going to talk about what is an object. You can't do physics without objects, right? If you're going to talk about location, distance, motion, dimension, right? All those words need to be defined properly. Because otherwise they're going to create fist fights out there, because one person understands one thing, the other one understands something else. And I think
that's also that scarecrow strawman fighting thing that you run into, where you say, "Oh, look how black hole." This guy says black hole means this. Black hole is zero dimensional. Then this guy comes and says, "No, I never said that. I mean this other thing with black hole."
Yeah, infinitesimal.
They just keep moving the goalposts. It's like, okay, pick one so we can tear it down.
Yeah.
That definitions make it
And yeah, what I'm saying is that infinite does not, or infinity does not mean unbounded. It means incessant. Okay, incessantly. You're moving. You're talking about motion. You're saying you're going to measure. And if you look at the synonyms that you find in the dictionary, the only one that refers to a thing for incessantly is the word continuous. But that continuous is what we use in physics as an adjective. It is an adjective, not an adverb, right?
Yeah.
And it means something made of a single piece. Other than that, all the other ceaseless, constant, all those refer to motion.
I didn't know we were learning English.
Yeah, in fact, you got to start with definitions in science. Right?
In fact, I even told you like a week ago that it's almost like a new branch of science, which is semantic sciences, because so many of these words just get thrown around, and we never get to the bottom of anything because we're just going in circles. And you've seen that when you see debates,
because of the
lack of definitions. When you get into all these philosophical debates, philosophy is also a branch of science. When they never define the word truth, or they don't define the word God when they're trying to actually get to the bottom of the word God, like theists when they're talking about it, because they don't want to chop off parts of it. Because like, no, I mean that too, but if you mean too much, then it means nothing.
Yeah, you cover all the bases,
and then you just end up going in circles, and then everyone feels like they had a productive discussion. Everyone looks smart, but
everybody walks out there. Oh, that was a
great time. What the heck did we talk
about?
No one defined a single word.
Well, here you have one fella. Everybody knows, I think, or remembers him. His name is Stephen Hawking.
That's a lot of text.
And he says the universe is not infinite in space, but neither does space have any boundary. What? What do you mean?
The universe is not infinite in space,
but it doesn't have any boundary. Okay? Neither does space have any boundary. Okay? He says gravity is so strong that space is bent around. He says he's going to curve the space around, turning it into a ball of some kind, right? A curve, right? And if one keeps traveling in a certain direction on the surface of the earth, one never comes up against an impassable barrier. So he's talking about two things. On the one hand, he says finite, and the other one, he says unbounded, when he really means incessant walking or incessantly, right?
Yeah.
Perpetual or whatever. One thing is finite, meaning, any ball is finite. Take your bowling ball, you'll find out it's finite. And then if you walk around the bowling ball, assuming you could, right? Or you walk around the earth, you're not talking about the same thing. Now you're talking about motion, and you're talking about really incessant walking, or you're talking about perpetual or something along those lines. So my conclusion is on this is the following, okay, is that a mathematician, it's an individual who doesn't understand the difference between an adjective and an adverb. Okay, he's talking about finite, which is an adjective, and then he's confusing that with incessant walking or incessantly, which is an adverb. And this is the problem with the language. That's why language is so important in physics, right? In science in general. And people don't pay attention to language. They say, "Oh, I understood," when they didn't understand squat.
But the thing about it is, it isn't only the language, because you could also do a visualization, but they can't do that either. So in the end,
why? Because they're using concepts. Again, it's language.
It doesn't matter whether you use words or images, they can't get the message across, because the message is BS.
Right, because they're trying to give you a physical interpretation, and there's nothing physical about it.
There's nothing to convey.
Concepts, mathematical concepts, which they introduce as physical objects. Say, "Oh, I'm going to warp time," or "I'm going to,
travel through time.
Travel through space. Space is nothing. You can't travel through space or time. But they do that, and they bend the dimensions.
If you don't call it travel through space, what would you call an astronaut going from Earth to the moon?
Exactly what you said. You go to an object.
I
don't travel through space. You can't travel through nothing.
Well,
you can travel through water. You can travel through air.
Yeah, travel through air.
But you cannot travel through nothing.
Oh, that's weird.
I can't travel through nothing. I can travel only through something.
Because that would be reifying space into an object.
Right, you're reifying. You're saying space has shape. Okay, then draw space. Draw the figure of space, so that I know that I can travel through it.
Yeah, it's splitting hairs, but I guess if I said travel through space, I mean, I hope I'd be forgiven for.
Okay, so here we have another issue related to that. Okay, here you have a fellow walking all around the earth, right? That's incessant walking. And the question is, good old Hawking, he says there's no bound. And he's wrong on that issue too, because here you see that there is a boundary, okay? It's the starting point where he left. He's covering the same ground. He's seeing the same atoms again, okay? So you can't say that I haven't encountered an obstacle. The obstacle is the finish line. That's what the obstacle is. Because now you're going back to Africa if that's where you started from, or back to North America if that's where you started from. Now you're going back to the same atom you started from. Okay, so you can't say, it's like if you go through every atom in the universe, right? Let's assume you can do that, you live eternally. You go through every atom in the universe. At some point, if there's only a fixed number of atoms, you're going to come back to the starting point, to that first atom. And so you can't say you walk incessantly throughout the universe in that case, which is the case here, right? You have to come to a finish line or to your starting point, whichever one you want to think about. Okay, so that's another thing you got to keep in mind. And what's worse is what they do next, and this is really should shock you. Okay, what is it? When they take a sphere and you focus in more and more and more on the edge of the sphere until, it's so big that it's almost a flat, straight line.
Like the Earth.
Right. And so this is where they say the Earth is finite, but it's also unbounded because it's flat and, the plane is infinite. Well, no, we got to keep it in the right context. If you started with a sphere, there's a curve there, and the fact that you, the observer, you, the measurer, the person who's measuring, cannot measure much of a curvature is irrelevant. You can't say, oh, it's completely flat. No, it ain't. And you can't say that it extends forever, meaning infinite, right? If what you're talking about is a sphere, there's always going to be curvature. You can't avoid it. And that's something for all flat earthers to think about.
I mean, if mathematicians are making the logical jump of making a ball straight, those are imprecisions that aren't really what mathematicians do. So I'm guessing they're just flat out lying.
Yeah, this is what they do. Yeah, watch it. I've illustrated it here.
Yep.
Okay. You have the sphere. Now you zoom in on the edge, right? You're going to zoom in all the way. And what are you going to come up with? Well, they come up with a straight line, which is the end result of this, focusing. Right, so they end up with a straight line and say, "Oh, the Earth is the universe is infinite, or the Earth is infinite, or the circle is infinite." No, it ain't. A circle has curve, and I don't care how much you zoom in on that circle, it ain't gonna be a straight line ever, much less an infinite straight line, which is the way they always picture it. This is what the mathematicians do with all their math. They say, "Oh, it turned an infinite straight line." Okay. And so you can't do that. You can't say a circle, if I zoom in, at some point I'm going to end up with a straight line. No, it's always going to be a curve. Sorry. And it's never going to be an infinite straight line for sure, because that's talking about going around the circle. Again, we have to keep things in context, and the relativists don't do that, okay? And so what do they end up with all this after doing all their calculations and all that stuff? Well, they end up with these three universes. Either we have the finite spherical universe, or we have the other two possibilities, which is the flat or the saddle-shaped infinite universes. And the problem here is they start out with a finite universe with a sphere, and everybody more or less has to visualize that that's the case, because Big Bang happened at a single point, single time, right? 14 billion years ago. It's been expanding like a hand grenade, so you would think it's more or less spherical, right? And they say, well, yeah, that's Big Bang, but when we measure, we find out that it's infinite, like the flat board that you see in the lower right. And so and how do they reconcile these two? They say, well, if you focus in very closely to the edge of the sphere, you're going to find the infinite flat plane. That's how they do it. And so they get away with both worlds. They say the universe is spherical according to Big Bang, but it's also infinite according to, for example, the WMAP measurements.
It's finite and infinite.
Yeah,
it depends on what we need.
The only one they avoid is the saddle. I guess they don't like horses or something.
That one's harder to explain, so they stay away from that one.
Yeah, but see, because they say it's open-ended. But this is the issue is they're covering all the bases essentially. They're saying it's spherical and finite, but it's also infinite because it's a plane. And how do you get to the plane? Well, just focusing on the surface of the Big Bang as it's expanding, and so big that for us, it's for all practical purposes, it's a flat line. And it's an infinite flat line because all planes are infinite. That's how they solve it. Yeah, and so what we have to do is teach them something here, and it's got to do with, what is the center of some of these figures that they're talking about. Well, here you have a square, or, a rectangle, right? Okay, I hope you all understand what a rectangle is, right?
Wait, before you go on,
Yeah.
the center of something, does the shape have to be symmetrical?
No, because then you have the issue of mass, whether you have the center of mass, which would be lopsided usually. That's one issue, like the center of the earth and not the exact center, I'm sure. But then you have perfect geometric figures like the cube and so on, which are symmetrical, and you can say, okay, I can fix that center for sure. But then you have, rhomboids and so on. You say, well, where's the center of this thing, And again, you have those situations. Okay, but here's a rectangle, okay? I hope you all understand what a rectangle is.
So far, so
and
good.
Here's a circle or a disc if you prefer, okay? Here's a triangle. We have to do baby stuff here. I'm sorry, because there's a lot of people who don't understand what I'm going to say next, okay? And so I hope you've got all those figures way in your head, okay? Got them all?
Is there gonna be a test on
this? Yeah, there's going to be a test on this. And now here's the infinite rectangle, okay? Here, watch closely. Here it is. Okay, that's the infinite rectangle, okay? And now let me show you the infinite circle.
Yep.
And there you see it again. Okay, and here's the infinite triangle. Okay, you got them all? Okay, it'll be a test on Friday. Okay, the infinite triangle, the infinite circle. Okay, yeah, if you have infinity,
it's not a shape.
First of all, you don't have a shape. You can't talk about a figure, which is what the geometry was supposed to be about, right? That's one issue. The other one is, where's the center of this thing? I mean, if it's infinite, assuming, let's just concede for the sake of argument. Okay, so it's infinite. You got an infinite square. You got an infinite circle, infinite triangle. Great, no problem. Now, where's the center of this infinite thing?
Well,
how do you know if it's the triangle, not a circle or a square?
Well, if you're talking about the perspective reality people, then they'll say wherever you're looking, the center of where you're looking would be the center of that.
Center of attention.
The crosshairs.
Okay, so this is part of the problem. Okay, let's concede the infinite universe first, because we're going to try to find the center of this thing, right? Okay, so here you are. You're in your little rocket ship, okay? You're going to be flying around, okay? You're going to fly to infinity.
Yep.
And you fly, you live forever. You're like God, right? And you're going to fly forever throughout the universe, okay? And the question is, can there be such a monster as infinity, where you travel forever? You don't die, right? You're there awake all the time. You can put your mind in the rocket, just say it's my mind traveling, no problem. I do it any way you want, right? You're traveling forever. You're saying you're not going to find an end to the universe. What does that mean? I mean, you could say that space is infinite, assuming
the black
you conceded. How about the matter? Is the matter also infinite? There's infinite matter, infinite atoms. There's never a point where the number of atoms stops or space itself stops. What are you talking about then? Well, what is infinity? And again, for that you need to define infinity, and you have to define infinity for objects. You can't say, well, it's incessant walking, incessant traveling on my spaceship. No, you have to relate it to physics, and physics deals with objects. You have to tell me, if you're going to talk about matter, if you're going to talk about space and treat space as a physical object, then you have to define what you mean by infinite space. What is infinity?
I really love
an infinite object.
I really love the gift that you put there, because I instantly thought of, because I develop video games, the way you fake infinity, like that gift, is you take the dots that go off screen and you put them on the front like a treadmill. And you have it going like this.
Yeah, which is incessant motion and not infinity.
That's as if you were traveling on. That's as if you were traveling on a hamster wheel. Yeah, but that doesn't mean there's an infinite number of stars. It's just you're recycling them.
One is that you're going to come back to the same stars. Yeah. That's one issue. But the other one is, in one case, you're talking about objects. You're talking about whether all objects are finite. So you can't use the word infinite in a context of objects. The other one is you're talking about incessant motion or perpetual motion, which has nothing to do with the shape of an object. Now you're talking about running around. One has to do with objects, the other one has to do with motion. That's the first thing.
Just as well walk in circles on this and call it infinite.
Right. Say if you're going to come back to the starting point or to the finish line, whichever one you prefer, then you're not infinite. You don't have to have a wall there like Hawking said. It's unbounded because you don't come up against the wall. But you came back to the same atom. That is your wall. Yeah. Okay, so you can't say it finite but unbounded. Yeah. What you can say is finite, but you can walk incessantly around it. That's the correct wording. Not to say it's unbounded. Unbounded refers to an object. Objects are bounded or unbounded. Not unbounded. They're all bounded, but he's misusing the language there.
By definition, you'd think that something that's bounded means that you could walk as much as you want on it, but at some point you'll be retracing your steps. That's what bounding means.
Exactly.
Sooner or later,
in that context.
Right. Sooner or later, you will touch on.
Important to get the context and the language right. Infinite, finite. No object that is infinite. Okay, so one fellow says, he makes a correct statement as far as I'm concerned, okay? He says there must be but there must not be infinite material objects in the universe. There is definitely nothing, also known as empty, unoccupied space in between objects. And yeah, that's the assumption we make here, that the amount of matter in the universe is fixed. You don't have unlimited atoms.
There is a number.
There is a number, we have to keep in mind that it's a dynamic situation. Maybe an atom turns into a neutron and vice versa. Okay, there's things going on, right? But this is the issue. The issue is we do not create new matter in the universe. Space does not convert into matter. Matter cannot convert into space. That's why the universe had no beginning. Could not have had a beginning like general relativity concluded. And
that's my favorite answer to the universe question when they talk about creation and all that. It's much simpler. Matter just always was. Matter always will be.
And here it is. Let me show you all that there ever was or ever will be. It's the single thread. That's all there was. Now this thread, right, which is out there, not that we'll ever see it like that. This is just a conceptual thing that if we untie every atom in the universe, every rope that connects them, that's what we would end up with. Where does this go? Well, from there we go to this. We go from the single closed loop thread to a universe in which all atoms are physically interconnected.
But this is conceptually, so it didn't really go from a single closed.
Well, I'm not saying that. What I'm saying is there was no process that brought from the single thread to all the atoms. I don't think there was a process.
This is just so that we can understand what we're talking about.
Right. And it's just a conceptual issue saying that if we were to untie or unknot
to unravel the universe to a closed loop thread, but only theoretically in consciousness.
And so I'm saying that the basic system is two atoms bound by a rope. Okay, and so what we've been seeing all these years, the wave is not a wave, a two-dimensional transverse wave. It's a rope that we've been pondering all these years, and they've mathematized it to extinction almost. I mean, we did so much math on this thing, and it was always a rope. That was how simple it was. Yeah. All we needed to figure out is what invisible entity is mediating light and gravity, and that's our suggestion there. Okay, that's what we propose as an assumption. And all these atoms form that, what you see on the upper right there, all the atoms in the universe are interconnected. And if we were to unravel that whole universe, we would end up with a single closed loop thread. It'll never happen, never happened. It's just we're trying to analyze it conceptually. Okay, so let's keep that in mind. Okay, so
I love the concept of a finite ball universe because it kind of puts to rest so many of these questions that just never have answers. When you conceptualize it like that, answering a lot of big universe questions becomes much simpler, I noticed.
Yeah, because it's baby stuff then. Anybody can understand because you can see it there in front of you. Yeah. Doesn't mean you have to believe it, but at least you make sense of it.
Yeah.
You don't have to believe it, you just got to make sense of it.
I mean, if you can answer much more questions like that, then you think that that's the right answer, right?
And here we have Father Universe. Father Universe exists in a single frame of the Universal movie. Okay, that's what he looks like. That's his face. Yeah, he's
two galaxies, a planet.
That's Father Universe. Every atom in the universe only has location. That's all Father Universe recognizes. Father Universe, Mother Nature, God, the devil, whoever you believe in, right? It doesn't matter. All we have is atoms in the universe, everyone at a given distance from each other in one frame of the universal movie. If good old God or the devil could take a snapshot of the universe for us, this would be a 3D special type of photograph where you can see every atom in the universe, right? That would fit in a single frame. Yep. So there is no such thing as time for Father Universe. That's why he's eternal. He's eternal because he's in a single frame of the universal movie. He is timeless, should we say?
What are we trying to answer here?
Well, I'm saying that, if because I'm getting to the point of the center of the universe, right? So if the center, if good old Father Universe, right, fits in a single frame, all we have to ponder or visualize, right? Every atom in the universe. Just imagine you could visualize all that, all the atoms in the universe. And we're going to freeze the entire universe. We're not going to have any motion. So time and motion, they play no role here. All we have is existence, right? Single frame.
Yeah.
Every atom there. What would the universe look like first? And then if we can more or less imagine that, can we figure out a center of the universe? In this case, his nose is in the center.
So you're saying if we zoomed out on the universe.
Right. If we could be a bird's eye perspective, right?
Yeah.
If we can have a bird's eye perspective,
God's eye
we're sitting there next to God, right?
Yeah.
We're looking at
chilling with them. Would it be a ball we're looking at, a donut, a cylinder, a triangle?
So here's a couple ideas. Here's one. Imagine that all atoms in the universe, meaning all planets, all stars, all galaxies, they form from a bird's eye perspective, right? They form some kind of ball, right? That's one possibility.
This seems like the first thing we would think of.
And the issue here is that one thing is that the whole thing could be moving. And here I put it rotating clockwise. It could be in different directions, right? But one thing is that here we have also almost a perfect ball. It doesn't have to be so perfect, right? But gives you an idea what you would see for the universe if you were far away. The amount of matter has to be fixed.
Yeah.
In other words, some of those atoms can turn into neutrons or whatever, or maybe the rope extends in one direction and one atom disappears. I don't know. All these little details have to be ironed out.
But whatever
I'm saying the amount of matter,
there.
the single thread, if we were to unravel all these atoms, would be a fixed amount because a single thread does not extend. It's not a rubber band, okay? It's just a fixed amount of matter, we could say. And forms a certain amount of matter that forms our universe. What's the black stuff that continues, infinitely? No. The black stuff is that which has no shape. That's why it's infinitely.
Because it is, by definition, not something.
Right, it's not something. So
I guess it's the only thing.
Use an adjective on it.
Like just in ordinary speech, it might be the one thing you could call infinite, even though it isn't something that.
Yeah, but we need to get the wording proper in there. You can't use the word infinite at all because if it's an object, it's finite, and if it's
it ain't
space,
an object, then
it ain't an object. You can't talk. You can't use an adjective.
There's something weird about that gift though. Seeing all the matter like in front of you. Yeah. It's just kind of weird.
Well, here's another version. Okay, this is another possibility. We're not going to cover the million ones, but here's a donut-shaped universe. Okay, and we were discussing with Aunt here the other day this thing whether the universe could be like donut-shaped, and they do talk about that. These are different possibilities. And one of the reasons we went with a donut idea is that you have atoms on one side. Let's say the east side of the donut, and you have atoms tied to them that are on the west side of the donut. The advantage of this model is that you don't have gravity towards the center of the donut because the center of the donut is nothing. There's nothing there. Okay, that's the idea, or something for you to ponder. You can go out there.
You would have gravity towards the center because.
But I mean, it's unlike the Earth, where the Earth there's matter in the center.
Yeah.
Here's no matter in the center of this donut, right? And yeah, you have atoms on the east side pulling on the west side, north pulling on the south. You do have that. But what you don't have is a preponderance to go to the center of the donut. That's all I'm saying.
Well, the reason I was arguing for the shape of the entire universe being a donut was the magnetism. The way you explain magnetism.
Yeah, you're getting ahead of yourself. Hold it. Let me show that now. Okay, so now we're going to factor up because we have the issue. This is the problem. Let me tell you what the problem is. If all the ropes are pulling, well, all the atoms are pulling through ropes to other atoms, you know, you have all this massive, all these atoms on one side of the universe pulling on atoms on the other side of the universe. Yeah. You know, how do we handle this? Because shouldn't everything go towards the center? Or shouldn't the whole ball compress itself and turn into a black hole or whatever they call it?
No, don't bring that up.
No, we don't want to bring that up. So what you have to ponder, another thing that we want to include here is the magnetic field.
Well,
magnetic field.
But what the question specifically is why has all the matter in the universe not collapsed onto a single ball or just gone out?
Which is what Newton asked. He said, why don't all the galaxies, well, he didn't know exactly about it. Why don't they crash and fall a single ball?
Why does matter keep its distance as it is? Not completely on one spot and not completely far away from each other. It seems to be that something is maintaining everything where it's supposed to be.
Right, and here's the one solution that we propose, okay, and that's the universal magnetic field.
I love this.
Okay, we have a universal magnetic field, and you have to imagine that all galaxies have a magnetic field, all stars have a magnetic field, all planets, well, not all, but a lot of planets have magnetic fields, especially if they're big. Yeah. And so the issue here is this would be the universal magnetic field. You have the universe, a ball type universe in the center, and you have all these threads that are just swinging around, and they're going to help push things apart or maintain a certain stability to the universe so that everything doesn't collapse gravitationally.
So the concept is something like any atoms that go to the center get slapped I guess in this case it would be slapped up.
Well, here you see here's the cylinder. And again, let's assume the cylinder is there and the magnetic fields go through the center of this, it will not allow any matter to be in that center. And that's why, in that case, the universe would be cylindrical, donut shaped.
Yeah. Any matter that goes too far out gets slapped back in. Any matter that goes too far in gets slapped back in. And it's almost like the bounds of our universe. In a way.
Right. So the issue is this is homework for anyone who wants to take on it. What is the shape of our universe? Maybe it's a cylinder shape. Maybe you can factor in a cylindrical shape or triangular, pyramidal.
I was personally rooting for the ball universe because I kind of like the idea of the ball having the same shape as an atom. Yeah. But the more I thought about it, the donut one makes more sense.
Yeah, the donut one, we like the donut one more. I didn't like the donut one a long time. I even discarded it completely. Now I'm bringing it back.
I kind of like the donut universe because
it might solve some problems.
Because the magnetism of the universe slapping. Yeah, exactly.
There's our universe, folks.
The magnetism, man, Homer Simpson would love this. But the magnetism slapping anything that goes to the center or too far out because it's literally going in and out.
In and out. So it doesn't allow any galaxies or stars to be in there.
Hold on, but I would say it's still not a perfect donut. It's more like a cone donut because assuming the magnetism slapping everything up, that means matter would shoot up and then come back in. So it'd be more like a cone donut. That would be my guess.
Yeah, or a thicker donut, maybe or a cylindrical donut, or something like that.
That'd be my guess.
That's homework for you folks. Yeah. We'll see you next week.
Oh, that was it?
That was it. Sorry. Bye-bye. Time's up. Bye-bye.
Well, we got comments.
Oh, we have comments in. Let's see if we can handle some comments here.
What is outside of space? More space?
Well, remember, space is not a thing. It doesn't have shape. There's no thing called space. It's nothing. Yeah. What is nothing? That which has no shape.
I don't think that question was directed to you. I think that's directed to
to someone. Well, I'm clarifying it anyway. It's a valid question. I mean, is there more space? And all we can say is there's no more space because space is not a more type of issue. You can't have more space. Space ends where the last piece of matter ends, in a sense.
One of the comments said,
Yeah.
"We don't use miracles or magic in science," but I don't know if I'd agree with that because you do have one miracle that you use with the ropes going through each other. Would you say that science, even your science, would need at least one miracle or one thing that we don't normally see in all day-to-day life?
That's the issue. The issue is quantum mechanics, general relativity, string theory, and the rope model, electric universe. All of them have a little bit of magic, and the magic is that you cannot you can have two particles at the same place at the same time in quantum mechanics. And here we're saying you can have the rope two ropes
On each other. Yeah.
or going through each other,
In the
touching each
same
other,
exact
etc.
location.
And so the issue here is that Mother Nature's invisible universe, the mediators that she uses, in this case the rope, the threads that she uses to do her daily stuff, they have different properties in our everyday world where we use atoms. We don't use the invisible stuff that she has to do our stuff. We can't use her threads and ropes to do something. All we can do is use them in the sense of if we're going to use light, one atom stimulates another atom. We can see and touch the other atom. We can't see the rope that serves as the mediator. So we can't use the rope. Okay, so in that sense, she has an advantage over us, Mother Nature, Father Universe, whoever, right? Because she can see and she can do that, but we can't. We can't do anything with the rope. All we can do is try to conceptualize it, visualize it, and say, okay, there has to be a mediator there, a physical mediator. We have the rope. Okay, now we have the physical mediator, but it doesn't have all the properties that we expect to see in our daily world, which is see and touch. And that's where the whole hang-up was all these years. People were expecting to see and touch, and we can't explain gravity. How come I can explain gravity? Here's gravity. Okay. Why does a pen fall down? Well, because it's tied at the bottom, right? So it fell down, right? And here we have another. Well, give me another pen. Okay, so here, get a pen.
Pencil.
Okay, so here we have another one, right? And so what do we have now? I'm saying now I let go of this, and it also falls to the ground. And you say, well, this one I can explain because I can see and touch what's pulling it down, right? And here I cannot see or touch what's pulling it down. Well, yeah, because it's invisible and intangible. We can't grasp that thing that Mother Nature uses. That's the only difference. Okay, so we have to put it in the right context.
I guess two more questions.
Okay.
One of them, I don't know where I had it, but can science explain conscience? Not conscience,
Consciousness.
But consciousness, sorry, yeah.
Consciousness. The issue with consciousness, I think, is very simple.
Yeah.
Mind, consciousness, thought, whatever you want to call it, okay? Soul, spirit, any of those? Mm-hmm. For me, it's all the same. It's a thinking process that we have inside the brain.
Yeah.
Without the matter in the brain, I mean, if we could kill all the atoms and they don't move anymore in your brain for whatever reason, or just shake a little bit, but not like when you're alive, then you don't produce consciousness. That means consciousness, soul, whatever you want, spirit, whatever you want to call it, has its source in matter, okay? Yeah. And I'm saying part of that process is a electrochemical reaction, and another one is the magnetism we have inside our brains. So we have all these atoms moving in there, not only the atoms, I mean, you have fields, as they're known in mathematics, right? You have the threads moving around in there in different parts of the brain, and that creates certain motions inside the brain that allows you to think and have all these, visualizations, imaginations, and so on. But you have to go back to matter. It's a material world. Ultimately, it's all atoms. Atoms and rope. That's all there really is. The rest is what? Mere opinion, as Democritus said once.
And someone, I've seen your explanations of current going through the wire, and it seemed like atoms swirling in place and acting upon further atoms like a gear wheels. But that means that the wire is in motion, yet it looks like a solid. I guess it would be both, right?
Well, first of all, it's that they all rotate in situ. Okay, so you have a serpentine, as I call it, of all these merged, not really atoms, they're molecules, but it's easier to explain with atom. That's the only reason I use atom. And I try to use hydrogen atoms because it's the simplest atom. Okay, so just imagine a whole bunch of merged hydrogen atoms, right? The simplest atom. And they're twirling in situ. When they do so, the threads come out. In other words, out of the ropes and out of the atoms, they come out and they form this wall of threads going around. What's moving around is the so-called magnetic field. In other words, the magnetic field is made out of countless threads that have their origin in those atoms. Then electricity, which goes 90 degrees to it, because this one goes like that and this one goes like that, right? And so what you have is the rotation, which causes some kind of pressure at the end. That's what we call electricity. So why is electricity so swift? Why is it, when you turn on the switch, you have the light on, right? How did that happen? How did it go from the switch all the way up there? Well, because everything rotates in situ. Nothing has to travel. That's the issue. And if you use the model that Niels Bohr created in Rutherford, which is the planetary model, you have the little bead moving from one atom to the other. And so the first question is, why would one atom push the other one out, or why wouldn't one atom fill the space left by the other? That's one issue. The other one is, does one little electron have to travel all the way from negative to positive pole? And here we don't need that. If we rotate in situ, the impact is instantaneous. You could say almost instantaneous.
Why do superimposed ropes pull as one? Wouldn't the tensions add up?
No, because it's the atom. First of all, the ropes don't pull. We have to keep that in mind. We're so used to talking about pull, and I use the word pull many times as well, erroneously. Okay, I want to clarify that. There's only tension. Tension is not a pull, not a push. Tension means no one wins the tug of war. So you have a bunch of atoms here and fewer atoms over there. They're not pulling or anything. It's just that because one atom is approaching, or an object made out of many atoms is approaching the other, the ropes fan out. So the process is not that the rope is pulling. There's no pull on the rope. There's tension on the rope. And all you're doing is having one object with many atoms approaching the other atom, and they're eating through the rope. Remember, the atom is made out of the same rope, the same threads. So they're eating it. It's reeling in. Yeah. It's like reeling in. They're moving through the ropes, but as they get closer, the object has many atoms. The atoms that were behind another atom now are not behind it exactly. Now they're all, as they approach the other object, the ropes fan out because the atoms are not superimposed on the same axis.
But that was the question. The atoms that are superimposed on the same axis, why do their tensions not add up in a way?
Oh, because it's I do it with a rubber band. Let's see if I can do it with this one. I do it with a rubber band, and you can do this at home, always in the presence of relatives. So you trained relatives. Pull on that little bit. No? Okay, yeah, hold it. No, first don't pull. Get your finger.
Make it visual for them.
Okay, get your finger closer to in between mine two.
Yeah.
Right there. No. So you can just touch it. Just.
I mean, it's so they can see.
Okay, so can you feel the pressure or anything? No, you don't feel any tension. Now move it to the side. Now you feel something.
Yeah.
Okay, so what happens when we're on the same axis? It's like he's just holding on to the rubber band. He doesn't feel any pull or tug or anything. It's only when he goes to the side that you suddenly feel tension. And this is more or less what's happening. If you have one atom right behind the other, it's like the only guy pulling, right, on the entire tug of war is the guy at the end, or maybe the guy at the beginning. It's when they separate, that's when you feel the tension, that you feel more tug, which is the acceleration of gravity.
But surely you'd think that if it's hard. I guess it's hard to imagine a constant tension, not a pull or a push. I guess not a pull. Let's just stick with that. There's no pull, but you're reeling something in. That's hard to imagine. The tension is always the same, but you're reeling something in just because they happen to be coming closer to each other.
Because the tension never changes.
Weird.
Remember, because every atom in the universe is pulling on your atom. So you have pull from every atom in the you're pulling against the web. It's like the web of a spider, right? You have that tension there.
Yeah.
Right? And all we're saying is that when the atom moves, it really doesn't affect that tension. That's why the velocity of light is constant as well. All you're changing is the frequency in exchange for wavelength. C equals frequency times wavelength. One goes up, the other one has to go down. It's inversely proportional. But the speed of light remains the same.
Okay, one last question.
Okay, last one.
Have you ever thought of selling T-shirts with dumb quotes of mathematicians and some smart ones from the role model?
I would have so many quotes to quote. I would never end. I would sell so many T-shirts, all of them unique. Okay, folks, I think we'll see you next week. Okay, bye-bye.
Cannot define what a woman is, no.
Bye-bye.